In this lesson, you're going to learn about conditional probability. Consider the following example. There are 12 girls and 15 boys in a class. 7 of the boys and 8 of the girls are left-handed. Complete the two-way table below to represent the data given in the scenario. Then use the table to find the probabilities below. There are 12 girls, so I can put 12 as the total in the row for girls. There are 15 boys, so I can put 15 at the end of that row. 7 of the boys are left-handed. 8 of the girls are left-handed. I now know the total number of left-handed is 15. Well, how about right-handed? There are 7 boys who are left-handed and 15 total, so that means there are 8 right-handed boys. This line must add up to 15. So 7 plus 8 equals 15. If there are 8 left-handed girls, then how many are there if the total is 12? There must be 4 right-handed girls. And now I can look at the right-handed column and add those together to get that there are 12 total right-handed people in the class. And then looking at my totals, I can add going down to get 27, or I can add going across to also get 27. Number 1, P of boy. What's the probability of being a boy? I would start with boys and go all the way to the end and see that there are 15 total boys out of how many total students there are in all, and that's 27. So the probability is 15/27, and we can reduce that. 5/9 would be the simplified form. Number 2, probability of being right-handed. Well, how many people are right-handed? Here's right-handed. Let's go down and see that there are 12 total right-handed people. Out of how many in all? Well, that would be the total. There are out of 27 in all. And then this can be simplified as well. So that would be 4/9. Let's go down. Number 3, what's the probability of being a girl and left-handed? That symbol right here, that's the upside down U, means and. So the probability that you are a girl and left-handed, we're going to have to look at the intersection of girls and left-handed people, and that would be 8. So 8 would be our numerator, and that is out of the total number of students, which is 27, so 8/27. Number 4 introduces a new symbol. It is, what is the probability of being left-handed given that the person is a boy? That vertical line means given that. So to answer this question, we have to start by saying it is given that the person is a boy. So we're only looking in the selection of boys. So that only involves a total of 15 people out of 15. What is the probability of being left-handed? Would be 7. There are 7 left-handed boys, so 7/15. Number 5, what is the probability of being a boy given that the person is left-handed? So we're only looking at those who are left-handed, and there are 15 total people who are left-handed. What's the probability of being a boy? How many boys in that selection? There are 7. So 7/15. And these happen to be the same, but they don't always have to be the same. Number 6, what is the probability of the union of being a girl and being a boy and right-handed? Being a right-handed boy and the union of that with the probability of being a girl. So let's remember that union is essentially saying or. What's the probability of being a girl or a right-handed boy? So let's use some colors here. We'll say the probability of being a girl, and that's 12 out of 27. Or being a boy that is also left-handed. This upside down U means and, the intersection of. So how many boys are also right-handed? that would be 8. And that's 8 out of the 27 people in all. Well, we have now 2 separate probabilities, and there is no overlap. So we can add those together to get that 20 out of 27 people would either be a girl or a right-handed boy. Now that we've looked at a variety of probability scenarios, 2 of these were conditional probability scenarios. Number 4 and number 5 were conditional. They have that vertical line which stands for given that. Now I want to talk about what conditional probability is. I'll read this together with you. The probability of an event A given event B has already occurred is notated as P of A given B. To find the probability of A given B, we can use either of the following formulas. One of them is that it is the probability of both A and B happening divided by the probability of B happening. We're only looking at B having already occurred, so that's why the denominator is the probability that B has happened. And then the top is the probability of A and B, because we're assuming B has already happened, and then we're looking at what's the probability that A happens, given that B has already happened. That's why it's the probability of A and B. Another way to write this is that it's the probability of the intersection of A and B divided by the probability of B. And there are other ways to do this, but we'll go with these for now. Let's look at some more scenarios together. Number 1, what is the probability that you drew a heart given that you drew a red card from a standard deck of cards? If you drew a red card, then you only have 26 cards total. So you know it has to be one of those 26 red cards. What's the probability that you drew a heart? How many hearts are there? That's 1/4 of the cards that are hearts. So that would be 13. So 13 out of 26, or 50%. Number 2, what is the probability that the face card that you drew from a standard deck of 52 cards is a king? So it says here, the face card that you drew. So you drew a face card. So let's think about how many face cards there are. Jack, Queen, King, and there are 4 of each of those. So that's 12 cards in all. So that's our denominator. What's the probability that one of those cards is a king? Well, there are 4 kings, so 4 out of 12, or 1/3, or 33.33%. Number 3, a bag contains 24 yellow candies and 76 red candies. 1/4 of the candies of each color are Skittles, and the rest are M&Ms. That means of the 24 yellow candies, 1/4 of those are Skittles. So that would mean 6 are Skittles. And then of the 76 red candies, 1/4 of those are Skittles. So that's 19. What is the probability that a randomly selected Skittle is yellow? So you have selected a Skittle. How many Skittles are there in all? Well, we have 19 red and 6 yellow. So there are 25 in all. So I know I'm looking at, out of 25 of these possible Skittles, what's the probability that it's yellow? Well, there are only 6 yellow, so 6 out of 25, or 24%. Now this isn't out of the whole bag. This is saying if you selected a Skittle, what's the probability that that Skittle is yellow? Part B, what is the probability that a randomly selected yellow candy is a Skittle? So we have selected a yellow candy. There are 24 yellow candies. If we're selecting from the yellow, what's the probability that it's a Skittle? There are 6 Skittles. So that probability would be 6/24, which can reduce to 1/4, or 25%. Number 4, contestants on a game show run through 2 obstacle courses. About 45% of contestants successfully complete both obstacle courses. If about 60% of contestants successfully completed the first obstacle course, what is the probability that a contestant who completes the first obstacle course will complete the second? Conditional probability says that the probability of A given B is equal to the probability of A and B both happening divided by the probability that B has happened. So in this case, the probability of A and B both happening is 45% because 45% of contestants successfully completed both obstacle courses and 60% of contestants successfully completed the first one. So this is saying if somebody completed the first obstacle course successfully, so that's the denominator, our 45% out of 60% is the same thing as 45 out of 60, which is 3/4, and that would be 75%. To look at this with actual numbers, suppose 100 people attempted the obstacle courses. 60% of them successfully completed the first obstacle course. So that's 60 people who completed the first obstacle course. Now, 45% of all of the contestants completed both obstacle courses. So that would be 45 who finished both. There are 60 who completed the first one and now attempt the second. And we know that 45 completed both of them. So 45 of those 60 are going to complete both obstacle courses. And that also allows you to see that there's a 75% probability that somebody who finished the first one also finishes the second. So you see here, there is a formula you could follow, but you can also do this by just thinking about specific numbers and working through this scenario carefully with those specific numbers in mind. Number 5, 100 migraine headache sufferers participated in a study for a new medicine. Some were given the new medicine and others were given a placebo. After 1 week, participants were asked if they experienced a headache during the week. The two-way table shows the results of the survey. Part A, what is the probability that a participant who was given the medicine did not get a headache? So we're looking at those who are given the medicine only. The number who were given medicine is a total of 65 people. So out of those 65, how many did not get a headache? That would be 54 who did not get a headache. So 54 out of 65 is the probability. And we could plug that into a calculator. That's approximately 83%. Part B, what is the probability that a participant who did not get a headache was given the medicine? So now we're looking at those who did not get a headache. How many did not get a headache? That would be 76. Out of those 76, who was given medicine? That would be 54. So 54 out of the 76, and that's approximately 71%.